Here is an explanation for the answer to final exam question number 61 in Alternative Energy Demystified, 2nd edition. If you have the printed book, you'll find this question on page 323. We're talking here about an air source heat pump, also known as an air exchange heat pump. A device like this can heat your indoor air pretty well as long as the outdoor temperature remains above about what? And then we're given 5 choices. Well, 0 degrees or 0 Kelvin is absolute zero. You can't say that this statement is true, because if it were, that means that if it were 10 degrees above absolute zero, you could heat your house. Not so. Choice A is ridiculous. Choice B, 0 degrees Fahrenheit. Well, actually, 0 degrees is quite a bit too cold to get really good indoor heating with an air source heat pump. Plus 4 degrees Celsius, that is the correct answer. Plus 4 degrees Celsius. That's about 39 or 40 degrees Fahrenheit above zero. As long as the temperature stays above that, an air source heat pump will do a good job of heating your house. You'll be nice and comfortable. 0 degrees Fahrenheit, well, you might get some heat out of the thing, but it probably isn't going to be enough to keep you comfortable, so the words quite well wouldn't apply. So choice C is our answer. D, plus 72 degrees Fahrenheit, well, it'll certainly do that. I mean, the answer is correct in the sense that it will work above 72 degrees Fahrenheit, but you're probably not going to need to run your heat pump to heat your house if it's already 72 degrees above 0 Fahrenheit outside. You won't need it. So choice D is not the best answer here. It's technically, logically valid, but choice C is the one given in the book, and that's the one that applies here. How about choice E, 212 kelvins? Well, that's probably, let's see, about 61 degrees below 0 Celsius. That's way too cold. That's like Arctic cold. That's middle of the winter Arctic or Antarctic cold. So that's not a good answer either. Let's look at one of these things. Let's actually take a look at a schematic diagram or a simplified block diagram of a air source heat pump. What it does here is it takes heat energy from your outside air, as long as it's above about plus 4 degrees Celsius or plus 39 or 40 degrees Fahrenheit, anywhere up to whatever temperature is comfortable enough that you don't need it anymore. Takes heat energy from the outside, even if the air temperature out here is cooler than the air in your house. It'll take this heat energy, which exists in any object above absolute zero, theoretically, and it kind of operates like an air conditioner in reverse. You know how those air conditioners spew hot air outside during the summer? I mean, it's hot enough out there already. It's 90 degrees, 100 degrees Fahrenheit, and this thing is spewing hot air into the environment even more. You know, you start wondering, well, how much global warming is that going to cause? Well, not much, but this compressor will produce the same result, and instead of spewing that hot air out into an already torrid outdoor environment, it'll spew it into your house, which is cooler than you want, through a fan, and it'll warm your house. This air, though, doesn't get real hot. It isn't like a forced air gas furnace or a coal furnace or a wood stove. It doesn't have blazing hot air. It's probably 95 degrees Fahrenheit. So it's just warm enough. You need a good fan and a good circulation. And then the cooler air coming back from the rooms goes back in. And it recirculates by means of this good, powerful circulation fan. So that is how an air source, or also known as air exchange heat pump, works. But once again, the correct choice for this question is C, this thing will work very well as long as the temperature outside is above about plus 4 degrees Celsius.